research that and across Chai. And I thank you all for taking the time to come to this talk today. I understand it's the last day of classes, so I know it's a very busy time in the semester. So let's get right into it. So the goal of my research, as Rennie was just saying, let me see, is to develop AI systems that help people communicate across languages, and crucially to study how successful they are. A gap that we find across all of our studies is that we have AI systems that we develop on benchmarks, and our systems do better and better on these benchmarks. But when we put them in real world scenarios, they don't necessarily actually help people communicate better. So studying and trying to close that gap is a big focus of my research. And today I'm going to give you a case study of what that looks like in the area of machine translation. So I like to think of machine translation as the original generative AI application. I'm biased because this is like the first application I worked on during my PhD more than 20 years ago at this point. But there's been machine translation apps available online for decades already. And people use them on a daily basis for a lot of different things. Today, you can use AI translation tools not only with dedicated apps like Google Translate, but also with AI chatbots. You can ask ChatGPT to translate for you, and it gives you something. We can talk about how useful that actually is. But what we see is that as these tools become more commonplace, people use them more and more in, even more diverse settings. The gap between how the technology is developed and what people do with it is growing. Today, we estimate that the vast majority, more than 99% of users of machine translation apps are not translators. 15 years ago, it used to be that the people who use this app were mainly professional translators who were using these tools in their work to be more efficient. Often not because they wanted to, but because they were told they had to use them to be more efficient. Today, the situation is very different. People from all walks of life use machine translation, and they do not have training in translation. Work from translation studies and human-computer interaction gives us some insights into how people use machine translation today. So there's a nice series of studies by Lucas Nunes Vieira in the UK, where he did a series of surveys, first focusing on how people, like regular people, lay people, use machine translation tools. And he found that people do use them casually for non-essential purposes. But even in those casual settings, they wish they had access to tools that were better, that produce better translation. That was in 2022. AI moves fast. A few years later, in 2024, he did another survey that focused on public service employees. And he found that a third of them used machine translation tools at work, including in healthcare, police work, legal work, so consequential areas. But they had no training to use these tools. They just found themselves in a situation where they needed to communicate with someone and they didn't share a language. And so they just used their personal device, used an online app without any training to try to get their message across. An earlier study by Google focused on migrant workers in the US and in India, and they found that migrant workers rely on these kinds of tools for all sorts of use cases that have a big impact on their daily life, including seeking employment, navigating relations with their employers, looking for healthcare information, and so on. So these are all with translation tools like Google Translate. I was looking for what people do with Gen AI chatbots like ChatGPT, and I was on sabbatical in France last year. And so I found these studies of youth in France that found that 85% of 13 to 21 years old use Gen AI tools regularly, and translation is one of the top three applications that they use it for. So clearly, there's a lot of people who use these translation apps. They're very diverse. They have very different goals. And so what all these scenarios have in common, though, is that translation is not the end goal. It's a means to an end, right? It's a people trying to do something in the world, and they use translation tool. And that's exciting from as a technologist. It means like the kind of technology we're building has an impact. But also, it means that when the translations go wrong, when there are translation errors, this can cause real harms. So it ranges from, inconvenience, like in this case a few years ago when the Olympic team in Norway, I think that was in South Korea, used a translation app to order some food, and they accidentally got 15,000 eggs while what they wanted was 1,500. So in that case, it's annoying, it's expensive, but no one gets hurt. There are cases where translation errors, a term that was innocuous, accidentally got translated into an insult, I think from Korean to Chinese, which led to a fight that ended badly. In the US, there's evidence that inconsistencies in translation by AI translation tools have jeopardized immigration cases. And there are many such examples to the point where that a few years ago, Slate had this article titled Death by Machine Translation. So, thankfully, like the cases where translation errors like these actually cause death remain rare. But I think these drive home the point that the harms are real when translations go wrong. So a key question that I've been asking in my research in the past few years is how can we make machine translation trustworthy? Clearly, there's work to do to make the translation tools better, but I think like any AI tools, they're never going to be perfect. No matter how much the technology advances, there's always going to be errors. And so in addition to trying to make the quality better and better, I think it's also really important to think about how we can design the technology so that people can make good use of it, even if it's imperfect. That's a particularly challenging problem in the case of translation, because the people who need the translation tools the most are not qualified to verify the outputs, right? They're not bilingual in the languages involved. That's why they're using the translation tool. So they have no idea. They have no strategy to assess whether a translation is good enough to be used or not. So how can we use technology, use the kind of AI tools that we built to support them in this process instead of just leaving them to fend for themselves? So here's an example. So consider this scenario. We have a doctor here in the US who maybe is working in the emergency room and is discharging a patient who only speaks Mandarin, a language that the doctor does not speak. We know that in these settings, doctors often turn to Google Translate to take discharge instructions that have been written in English, translate them into Chinese, and show that to the patient under the assumption that showing them something in their language is better than nothing. The problem, of course, is that the translations are not always correct. And there's studies that have shown that in this domain, errors are not frequent, but when they happen, they can have clinical consequences. So in this case, we have the doctor in English is saying, stop taking this medicine. And the translation in Chinese says, keep taking the medicine, which clearly is a problem. So there's a problem here, like the traditional way of thinking about what the issue is from an AI perspective is that there's a translation error. So, we can try to build better translation models, AI models that do not make these errors. And that's useful. But another problem is that from more of an HCI perspective, human-computer interaction perspective, is that from the perspective of the user, if the error is hard to identify, right? If they only look at the Chinese, they have no way of knowing that that's not what the doctor actually meant. And even if they could identify the error, they don't have strategies to recover. How do they figure out a path forward to really get the intended meaning? So that's the problem we try to address. In a project that was a collaboration with faculty members in human-computer interaction, physicians, and myself, who is more of a technical AI person. The question we addressed in this project was how can we help physicians, like in the scenario I was showing you, decide whether a translation output is good enough to show to patients who do not speak their language. Crucially, we started from lots of needs finding studies that our colleagues in this project had run before. So our HCI collaborators had run interview studies with physicians where they found that they actually use machine translation tools to communicate with patients who don't speak their language in the real world. In theory, they should be calling interpreters, but in practice, a lot of the hospitals, like the UCSF hospital where our collaborator works at, don't have enough support from interpreters. It often takes a very long time to get a person on the phone. And so they turn to the tools like Google Translate a lot. Studies of the quality of the translations that we get from these tools have shown that they produce translations that are okay a lot of the time, but they do make errors that have a clinical impact. So what we ask is, like, as technologists, what can we do to help, to support people to do better, to not just leave them to themselves to decide how to use those tools? So as someone who's worked in machine translation for a really long time, my first idea was to turn to the literature, and there's a lot of work that's been done to automatically evaluate the quality of translation, automatically detect whether translations contain errors. The state of the art is something called Comet, which is a machine learning model, that a multilingual language model, you can think of it this way, that's been trained on human ratings of translation quality to automatically detect errors. Yep. Oh, sorry. Yes. Um, and hopefully the Zoom. Did it say hide? Here we go. Thank you. All right. So, right. So, I knew of all this work that's been, all this effort in kind of AI technical work to develop models that detect errors, assess translation qualities automatically by mimicking human judgments. And so my immediate thought was like, well, let's just use that, right? That, like, this should be useful. So we took the state-of-the-art methods for this. However, the scores that are produced are very hard to interpret. So on held out data, we converted the scores, the raw scores that these tools give us. Let me get my.
I think you need to take your mouse back.
Yes, I just need to figure out how to get back. Yes, here we go. So we converted the raw scores to something that's more readable, because if you tell people this translation has a score of 0.25, it doesn't really tell them what to do about it. So using held out data that's clinically relevant, we identified three categories from translations that contain critical errors, translation that are not perfect, but where the errors should not be impactful, and then translation that are overall good. And use that as a mechanism to show people, in addition to giving them the translation itself. The other thing we did is take the translation. So we had the English, it's translated into Chinese, and then we translated back with the same translation tool into English so that the doctor who doesn't speak Chinese can look at this back translation. As a machine translation person, this is something that worries me a lot, because it could be that this second round of translation introduces errors that were not there, or it could mask some translation errors that were there. So it's a very noisy way of getting insights into the quality of a translation. However, this is something that people do all the time. We found in needs finding studies that doctors are actually told to do that in training to verify the quality of translations. And then we know from talking to people who use translation tools, this is something that people do a lot, kind of intuitively. You might have tried it yourself. So we wanted to test it. And my assumption going in was that, this was just not going to be very useful, but I wanted to establish it empirically rather than having that as an assumption. So the study that we did is basically we showed doctors, so doctors had discharge instructions in English. They were translated automatically into Chinese. They and then they had access to two different types of feedback: the quality estimation feedback, like kind of the best of machine translation research so far, and then the back translation, kind of what people do in practice. And we asked people two questions. Would you share the Chinese translation to a patient who only reads Chinese? Is it good enough to share as is? And then we asked them about their confidence in that decision. So all participants in our study had to make this decision without feedback and then with feedback. And then between subjects, people were randomized into the two different feedback types. We did this with 65 English-speaking physicians who were reasonably familiar with this kind of scenario. Right? 45% of them interact with low English proficiency patients daily, and many of them had actually used Google Translate in these kinds of scenarios. What we're interested in is whether doctors rely on the AI translations appropriately. And so what that means in this setting is we are trying to see if they make the same decisions than a bilingual physician would make, right? Someone who both had the domain expertise as a doctor to understand the clinical impact of the information they're sharing, and the language expertise so that they can understand both the English and the Chinese. So what we are measuring is this metric called confidence-weighted accuracy, where for each decision, participants get a credit of +1 if their decision agrees with the one that's made by bilingual physicians, -1 if they disagree. And we weigh that with the confidence so that, if you make the right decision, but you're not very confident, you get a little bit of credit. If you make the wrong decision, you're very confident, you get a big penalty. So here's what we found. Here we are seeing the confidence-weighted accuracy across the two groups, the back translation group here, and the quality estimation here, baseline in light blue, treatment in dark blue. And we see here that showing the quality estimation feedback made the physicians better at deciding when to rely, while back translation did. Right, so far that's kind of what I expected. The state-of-the-art AI technique is more useful, and back translation doesn't help. However, we had to dig in deeper because we don't just care about making good decisions on average. In the settings, what we really care about is not passing translations that have clinically harmful content to patients. So here we partition the same graphs as before, except that we split the data into two. On this side, responses on translations that were correct, and on that side, responses on translations that were incorrect. And what we see here is a very different picture, right? Like the picture we had before basically is explained by behavior on good translation. So the physicians with access to the quality estimation feedback were good at deciding when to share the good translation. However, on the problematic translations, the quality estimation feedback actually doesn't help, doesn't make a difference, right? And even worse than that, this bar here is worse than these, the one that is back translation, which I was telling you I believed was not a helpful signal. So clearly here the results were really surprising to us. And digging deeper, we found that like if we go to some of the examples where the errors had a high clinical risk, the people who were exposed to the back translation feedback were better at rejecting the translations that had a clinically significant risk than the ones that were exposed to our state-of-the-art quality estimation metric. So this study led us to really rethink how we approach designing AI techniques for supporting people to make better decisions when using imperfect machine translation outputs, right? So to summarize, we found that quality estimation models can help people decide when to rely on MT overall, but back translation is better at identifying critical errors. So, there are different levels of lessons here. One, obviously, is that we're going to need a different type of intervention to truly support people in this use case. And then at a higher level, this highlights the importance of in vivo evaluations of our tools in use cases with human studies that go beyond the benchmark that showed that the quality estimation tools were the best way of detecting errors. So this leads me to the second part of the work, where we try to figure out, well, how can we use natural language processing AI techniques to help people rely on imperfect machine translation? This is work that was done primarily by a PhD student, Zoe Key, in collaboration with Kevin De at Johns Hopkins. So the approach we ended up using, that I'm going to tell you more about, is instead of predicting a score of quality or automatically detecting errors, we decided to use AI tools to ask questions and answer questions in a way that helps highlight inconsistencies between the source message and the translation. We think that this can be a mechanism to help discover errors, but also crucially to help people, users, engage with the content more and weigh risks of misunderstandings for themselves, make their own decisions about the impact of a potential mistranslation. This is motivated from lots of different threads of work. From a natural language processing standpoint, there's been work that's used question answering tasks as an extrinsic evaluation of AI tools for translation, but also for text simplification. Maybe sometimes you take text, you ask it to rewrite it in a way that's simpler. Asking comprehension question is a good way of verifying that the core message still gets across. So there's NLP work in that vein. We were also inspired by psychology work that looks at the kinds of explanations that are useful to people and that distinguishes between functional and mechanistic explanations. I think a lot of the kind of work we see in AI and in natural language processing for explaining systems decision is very much in the mechanistic direction, where we try to understand, well, how did the model reach a decision? What is it that went wrong? What is it that might be, what are the kinds of errors we might see in this translation output? By asking questions, we hope to move more towards a functional kind of explanation that prompts people to think about the consequences of the errors and what the errors mean in their context, as opposed to just evaluating quality in a vacuum. And then importantly, this aligns with real-world communication practices in the clinical settings that we're interested in. We know that asking questions is how doctors check that the patient understands what they're supposed to do, right? They might ask, so what would you be looking for to decide whether you're coming back to the hospital or not? And so given that doctors are already doing that, given that it's already part of the conversation, our hope is that designing AI tools that provide support through question and answer can integrate better in their communication practices. So we designed a framework that's based on large language models to automatically generate questions and answer them. So what that looks like is that we have the original message in English. We generate questions that cover the core content of that message. And then we also have large language models answer these questions on the basis of the original message in English and also on the basis of the translation. And what we're looking for is, are the answers consistent? If we get a different answer to the same question based on the source and based on the translation, it's probably a signal that something went wrong. So to tell you a little bit about how that works, so it turns out that you cannot just take a large language model, prompt it to ask questions and prompt it to give you answers. The questions that you get, if you just did it naively, are not useful. and are sometimes not even related to the text that you're giving as input. So we had to design a pipeline to make sure that we were covering the key content and only the key content that is in the message. So we do that by first extracting facts from the original input, then checking that the facts are entailed by the input, which helps us pare down what's generated, and then generate questions for each of these facts. Each of these steps takes an LLM with different levels of supervision. And then once we have the questions, we prompt the models to answer the questions. First, given the source, so that's kind of the straightforward part. The part that's a little bit tricky is how are we going to get answers to the same questions based on the translation? Because obviously the translation is in a different language, and we want to be able to compare questions in the same space, answers to the question in the same space. So there are multiple paths we can take. We can use a model that is intrinsically cross-lingual. We can translate the questions, or we can translate the text. And so what we decided to do is we tried all possible variations, and what worked best was back translating the translation. So if I have the English, it's translated into Chinese, we translate it back into English, just like what people did in the previous study. And so that's what's worked best empirically, but I think what's interesting is that it also connects with people real world practices, and we can think of the question generation and answering layers that we're adding as a way to help people make sense of the back translations in a more guided way. So once we have answers, both from the original source and from the round trip translation of the output, they're all in the same languages. And we could just show the answers to people. But of course, before we do that, we want to verify that our outputs are good enough so we don't waste their time. So we did an automatic evaluation where we automatically measure the distance between the answers that we get for the two paths. And so here, there are multiple metrics we can use to measure the distance, ranging from more naive string comparison metrics that just measure overlap between words to neural metrics that use representations that get more at the semantics of the message. So some of the validations we did were first entirely based on synthetic data, where we took good translations and automatically injected different types of errors into these good translations, and we measured whether our approach was able to make the difference between the good and the bad translations. What we found is that our approach is able to penalize the critical errors more than the ones that are just harmless variations, maybe using a synonym for another word. That's fine, like the meaning still gets across, but dropping some content or changing the meaning is obviously a bigger problem. And our question and answer technique is able to make the difference between these things. We also evaluated it on standard benchmarks that are used to develop quality estimation metrics. So here I'm showing you correlation with human judgments on to evaluate the quality of translations produced by machine translation systems in the biomedical domain. And these two bars here are what we get with our approach, with different ways of measuring similarity between answers. These are state-of-the-art metrics, the COMET metric that I told you about earlier, and metric X, which is a similar machine learning metric developed by Google. And these scores go in a different direction, which is why you see a negative correlation, but really what we care about is the absolute value. And so what we see is that our approach here, which takes a completely different approach, asking this question and answer, has correlations that are on par with supervised machine learning models, which is quite encouraging. The absolute values of the correlations are still quite bad, right? Like this is a hard task that's out of domain for all of these models. But what we're looking for here is how well are we doing at estimating quality when taking a completely different approach? And we're encouraged by the fact that we are doing as well. So that's great. But of course, our goal, as I emphasized at the beginning, is not just to do well on benchmarks, but to actually put these tools in front of people. We did a human study where we asked people, we provided this kind of quality feedback to people to find out whether they make better decisions about whether a translation is good enough to share as is. We didn't yet go back to doctors because doctors are expensive. So before we went there, we did studies with a crowd on Prolific. We still wanted to be in the consequential domain. So we're working with translations of COVID-related guidance. So that is originally written in English. We translated into multiple languages and ask people whether they think the translation is good enough, safe to share as is in their community, or whether it should be checked by a bilingual speaker. And we asked them about their confidence in their decision. So this is a way to, we're interested in whether quality feedback improved their decision making and the impact of different types of quality feedback. So this is a few years after the physician studies that I told you about earlier. So we had access to a wider range of feedback types, including highlighting errors in the output, which takes the machine learning models I told you about earlier, but as an explanation layer to find the parts of the output that that impact the quality score the most. You can also prompt language models to explain the quality of a translation. So we did that. And then we kept the back translation that people like to use. And we added the question and answer that we've developed in our work. We think of these part here as more of an explicit quality assessment where the AI tool is providing an explicit evaluation of quality. And those are more implicit. We never give users a score or tell them this is an error. We just give them a back translation, or in this case, answers to the same question and let them make their own judgment. So we had a similar study design, except that now we have 4 feedback types between subjects. This uses health relevant text drawn from a COVID-related data set. And then we had US participants who are English speakers and know very little Spanish, and we were producing translations into Spanish. So what we found here is that almost all feedback types improve people's decision accuracy. So this is the accuracy of decision, and then this is the confidence weighted accuracy that I told you about earlier. So the blue bars are the intervention, the pink is a baseline. So, they all do better with as AI assistant, except for the error highlights, probably because the highlights we're just highlighting parts of the output, which is in a language that they don't know much about. So that's not adding a lot of information. We see a bigger gap with the question and answer table, particularly when we take confidence into account. And both back translation and the QA table are the most promising metrics here, which we find interesting because these are more implicit methods of signaling translation quality. So to understand what's going on better, we looked at how people's decisions change first they make the decision without any AI feedback, and then we feedback. So we're interested in how their decisions switch once they see the AI feedback. Ideally, the AI feedback should help them correct decisions that were wrong initially and keep their good decisions if they were right at the beginning. So this is kind of the behavior we want to see in green here, where they make no switch if they were right, they switch if they were wrong initially. And what we want to avoid are the 2 cases in red, in dark red, over-reliance, where they were initially correct, but then in the presence of AI feedback, they made the wrong decision, or vice versa, they were wrong, and even with the AI feedback, they did not make the right decision. And so what we see here, so this is these are small numbers, right? So this is more kind of to understand what's going on more than definitive findings. But what we find interesting is that the reliance patterns are very different with the implicit feedback than the explicit feedback. We see that with back translation and QA table, over reliance is smaller than with, for instance, LLM explanations. And in addition, under-reliance is smaller with a QA table than with just the back translation. So by having access to the question and answers on top of the back translation, people are able to make better use of the AI feedback than if they just have access to the back translation. Looking at what people tell us about their experience with the tool is insightful to get a sense of how they perceive and use this tool. I think it's particularly interesting to see what people that had access to the LLM explanation said. They say, well, it gave me the answers. So, no wonder they have an over-reliance problem and just rely on the AI tool even if it's wrong, if they view the tool as just giving them the answer. By contrast, in the question and answer setting, we had more participants that were telling us in the first person, I could compare the words and make determinations. And so I find that particularly encouraging because it shows that, we're giving them support, but they remain like the agents in making their own decisions and making their own assessments as opposed to saying, well, the AI gave me the answer. So, to summarize, I briefly introduced a new question generation and answering framework that can help distinguish critical from minor errors. And we have initial human studies results that suggest that it can provide interpretable and actionable feedback for decision making. Of course, there are many open questions, ranging from technical question about how to do this question and answer process more efficiently. Right now, we have a lot of expensive large language model calls to do this whole process, and that could be streamlined and improved in many ways. There's lots of question about the interface and integrating this in many use cases that remain open, but we are pretty excited that we can use this framework that does things in a completely different way than the traditional supervised machine learning approach and get good results both on the benchmark and in terms of helping people. So I started out, telling you about the goal of my research to develop AI tools to help people communicate across languages. And so I told you a little bit about what that looks like in practice. Clearly, we haven't closed the gap yet, but I hope the talk illustrates the path forward, a path forward at least. I think it shows that the gap is real between the benchmarks that we use to develop most of our tools, where systems, whether they're translation systems or error detection or quality estimation systems, they can do really well on benchmarks while still causing harmful errors in real-world use cases. Our human studies also show that reliance decisions are hard to make for users and motivates trying to do something to help them. Human-centered methods reveal what benchmarks miss. Our user studies show which feedback actually helps and motivates technical natural language processing work that reframes translation quality estimation as question generation and answering. I think this work also shows that closing the gap requires iteration, right? We started out with some needs-finding studies that motivated our technical work, led to new studies that still don't fully answer the questions. We are currently working in collaboration with our HCI collaborators and domain experts on a new grant to take that back into the clinical setting and fully close that loop. Before I conclude, I also wanted to highlight a few other directions of research going on in my group that complement what I've talked about, still towards the goal of developing AI tools to support better communication across languages. One direction is to develop tools to support better AI literacy and AI translation literacy. The work I've talked about today was focused on feedback when people use the tool on a particular output. But we're also interested in developing things that are more like trainings that people could use to develop a better mental model of what is it that an AI tool can and cannot do when it comes to translation, so that they can use the tools better, even if they don't have feedback in real time. We also have kind of more foundational natural language processing work on understanding the capabilities of large language models when it comes to multilinguality and the fundamental tension between building models that are good at generalizing across many languages while preserving cultural alignment and cultural specificity. So for instance, we had a paper at EACL last month that used mechanistic interpretability probes to show that how languages are aligned internally in the middle layers of a transformer impacts whether they're able to give good answers to questions in languages other than English. And we're also really interested in understanding the reasoning capabilities of these AI models, particularly when it's not in English. And we find that models are good at reasoning in English, but they're not as good at reasoning in other languages, which is both practically a problem, but also fundamentally shows limitations. Like if models were truly able to reason, the reasoning should be language independent. And then finally, a big direction that I haven't talked much about, I have not touched on today, but I think is really important, is moving from text to all the modalities that actual communication requires. Working on text is like a natural starting point and where a lot of natural language processing work has focused on for a long time, but we've been ramping up work on speech translation and also multimodal question answering. I'd like to thank all the students without whom none of this work would be possible, and conclude and look forward to your questions. Thank you very much for your